Hello, in this video let's discuss third question of today's contest. You are given a positive integer n and an integer target. Return the lexicographically smallest array of integers of size n such that sum is equal to target and absolute values form a permutation of size n. If no such array exists, return an empty array. The constraints are n is up to 1e5 and target is from 1e10 to minus 1e10. For example, if n is equal to 3 and target is equal to 0, the answer is minus 3, 1 and 2 because the size is 3, it is a permutation of 3, the absolute values form a permutation and the sum is 0. So this is the answer for n is equal to 3 and target equal to 0. So simply we want a lexicographically smallest permutation that of length n with given size with given sum s. For example, we have 1, 2, 3 and we have 8 possibilities of permutations, right? Every element can be positive or negative. So 1, 2 minus 3 or 1 minus 2, 3 and so on. We have 2 into 2 into 2 which are 8 possibilities. So what are the possibilities of sum we can get from those 8? They are only 0, 2, 4, 6, right? 0, 2, 4, 6 or negative of above values. So why we are unable to get any odd number? So why are we able to get only positive number? Why are we able to get only even numbers? Because let's say we have 1, 2, 3, right? So if we are trying to make some elements negative, so for example we have 1, 2, 3, what is sum? Sum is 6 initially. And for example, if we are trying to make 2 as negative in the permutation, then what we are doing? So we are subtracting 2 into 2, right? So initially it is 2 and we are making minus 2. So what is the net difference that happened because of this? It is simply 2 into 2, which is 4. So if the initial sum is x, what will be the final sum after choosing any elements and making it negative? It is simply x minus x plus 2, right? Maybe k is positive, maybe k is negative, but some x will be converted only to x plus 2k. So both are of same parity. If that is odd, then we can get only odd. If that is even, then we can get only even, right? So first thing is we got how to find whether there will be sum or not. So we can find the parity of n into n plus 1 by 2, and if the parity of this and the parity of sum which we want is same, then we can get an array, else we cannot. So we already discussed it. So this must be even. If this is even, this also must be even. If this is odd, this must be also odd, else we can't get the answer. And now let's say we can achieve sum. How to get the lexicographically smallest answer? So that is the next thing, right? So if let's say we have 1 to 5 and the sum is 1, so let's start trying all the possibilities. As we want the lexicographically smallest one, let's try from the largest number. So for example, let's say we have 2 arrays minus 5 and all some other subset of 1, 2, 3, 4, and we have 5 and some other subset of 1, 2, 3, 4. Which can be our answer? If both can satisfy the sum, obviously this is this one, right? Because the highest value is negative, so this is the lexicographically smallest one. That's why we are starting from last n, and then we are trying from the last, because if we can get a permutation with that as negative, that is best. So let's say we have both possibilities 1, 2, 3, 4, 5 and 1, 2, 3, 4 minus 5. So for this, if this is the case, then what should be the sum from 1 to 3, 4? It should be 6, because the net sum is 1 and this is minus 5, so the remaining sum must be 6. And if this is the 5, then what is the sum about this? It should be minus 4, because the whole sum is 1, this is 5, this is minus 4. So now we removed one because this is 5 and this is minus 5. And now let's come to one smaller array. So we have 1, 2, 3, 4, and let's say we can keep 4 here, minus 4, 4, minus 4. So if this is 4, the sum from this is minus 8. If this is minus 4, the sum from this is 0. And if this is 4, as this is 6, this is 2. And if this is minus 4, this is minus 10. So if we clearly observe, this and this are not possible, because from 1 to 3, what is the minimum number that we can get as sum? It is minus 6, and maximum one is also 6, right? So minus 8 is impossible, minus 10 is also impossible. So these two are not possible. And then we only have two options, which is 1, 2, 3 minus 4 and 1, 2, 3, 4. And now let's come to this again internally. So what sum this should be? This should be 0, because this is minus 4 and we have used minus 4, so sum is 0. And the sum required here is 6 and we have taken 4, so the remaining sum is 2. So finally what we left? So we left with 1, 2, 3 with sum 0, and we left 1, 2, 3 with sum 2. If we clearly observe, these both are possible, right? So 1, 2 minus 3 or minus 1 minus 2, 3 is possible for this, and 1 3 minus 2 is possible for this. So anything is possible. So from this, are we able to understand anything? Can we get anything? So we got that, we got the answer for 5 and we got the answer for minus 5 also, because if we get the answer for minus 5 we also got for 5, because answer exists in both these branches, right? And now let's check how to find it. So firstly we have many options. So we got that we are coming from n, so that if that is negative then it is best, because we can get lexicographically smallest as possible. And now let's say we have sum is equal to 15, so 1 to 5 the sum is 15 and the required sum is 1. So then let's try to check how to find the answer. So what is the difference? So if we take 1 2 3 4 5 it is 15, and finally we want 1. So for example, if we are flipping some subset, for example if we are flipping from 2 to minus 2 or 3 to minus 3 or something, so the difference which should be formed because of flipping is difference, which is 14 here, because initially it is 15, finally we want 1. So 14 should be reduced, right? And how that will be reduced? It will be reduced by flipping v of I to minus v of I. Initially all are positive, so finally we will make sum as negative, so that we can get the required difference. So now let's come to 5. So if we are at 5, so first thing is whether we can flip or we cannot flip, right? So we have two options, we can flip or we cannot flip. So how can we check if we can flip? We can always flip, but we also have to make sure that if we are able to flip this, we have to get the answer. For example, let's say we are trying to flip 5 by minus 5, and finally if we are unable to make the answer, what is the use of this, right? So if this is plus 5 and we got the answer, then this is correct. So we should get as best answer as possible, not wrong answer, right? So now how to decide whether 5 should be flipped to minus 5 or not? So first thing is, when can we flip this? So if we flip this, what is the difference that we can get? The difference is 2 into 5, right? So this is 10. So if the required difference is more than or equal to 10, then we can flip this, right? Because initially all are positive and we are going to flip only negative. So there is no way that we are going to flip this negative again into positive. So we can flip any element only once. Maybe we are flipping 2 to minus 2 only, and then we will not try to flip minus 2 to 2 in any way. So we will flip only positive integers. So if we are flipping from 5 to minus 5, then what is the difference we can get? The difference we can get is 10. So the required difference is 14, and the difference because of flipping this is 5, is 10. So we can happily flip it, right? So it will be minus 5, because the difference is more. And then we'll come to the before one. So we have 1 2 3 4, and then we already got minus 5. And what is the sum now? So difference 10 is already achieved, right? So the net difference is 4, because initially we want 14, we got 10, so the remaining difference is 4. And now can we flip 4? We cannot, right? Because if we try to flip minus 4, so if we try to flip minus 4, then what will be the net sum? It will be minus 4 plus minus 5, which is minus 9. So if this is minus 9, is there any way to get a subset of 1 to 3 to make sum as 4? No, right? Because this is hugely negative. So even if we take plus 1 plus 2 plus 3, even then the sum will be negative. So which is ideally not. So from this what we want? So that's why we are checking if the required difference is more than or equal to 2 into present difference. So here it is not the case, because if we flip minus 4 we can't get the answer, right? So we won't flip this, so it will be plus 4 only. And then now what will be difference? Then difference will be 0, because we want 4, we got 4, so then difference is 0. And now coming to 3. So now coming to 3, what is the difference that we can get? What is the difference? The difference is 6. Can we get it? No. So simply make it 3 only, right? And now what is the difference? Now the difference is minus 3. Now the difference is minus 3. So if we do if we flip this, if we flip 2 to minus 2, then what will be difference? It will be 4. So we can add this, and now we want 1, so which we can use exactly 1. So if we check the permutation, 1 minus 2 3 4 minus 5, So positive sum is 8 and negative sum is 7, which is equal to 1. So from this, at any number we can check if that can be flipped or not. When that can be flipped, this can be flipped only if the required difference is more than or equal to the difference which we can do, which is 2 into v of I. Right? Only then we can do the flip, and then finally we can get the answer. So now, but we are missing one thing, right? But what is the proof that we can get the answer by flipping the highest value? That is one thing, right? Because what if we don't get any answer even by flipping all the values? Then what? So we have to get a proof that it will exist, right? Let's check that also. How are we sure that we'll get the answer if we start flipping from it? So if we flip 1, the difference changes by 2. If we flip 2, it will change by 4 and so on. So the required difference is only even. So now the main question is, every even number can be made using the difference that we can get. So obviously yes, right? Because every even number can be generated from this, whether it is 2 or 4 or 6 or 8 till 2n. Every number can be generated from subset 1 to n. So for 1 to n, we can generate all the numbers n into n plus 1 by 2 till n into n plus 1 by 2 by any permutation. So in this way, we are sure that we can get the final answer. So for 1, 2, 3, 4, 5, if the sum is 1, we can get by plus 5 or we can get by minus 5 also. So if there is a way, if we are able to achieve by minus 5, we can get the same thing by using 5 also, because this is like symmetry. Because if we flip this, for example, let's say we used x and we got minus x. So if we are able to make this succeed, we can make this also succeed. Because what is the difference between this? The difference is 2x. So we already discussed that we can make any permutation of even numbers, right, with the remaining digits, because this is 1 to x, this is one last number. So whenever we complete the number, the left numbers are still 1 to some number. For example, if we complete the iteration for x, then what we are left with? We are left with 1 to x minus 1. So even now we can generate all the even numbers difference, right? So that's why we are sure that if we get the answer by x, we can get by minus x also, because of symmetry. Because there is some subset by flipping some of these to get the required difference to x. So let's check this now more clearly. So this is 5 and this is minus 5. So now this is 4. So only minus 2 and 3 are same. Other 3, by changing minus 1 to 1, by changing minus 4 to 4, we are able to get the answer, right? So hope you got this. And let's check the code, which is exactly same. So initialize the values with I plus 1, and then the sum we can get is n into n plus 1 by 2, and then the difference is s minus x. And now start from the highest value. So if the difference is less than or equal to 0, then break. If the difference is more than or equal to twice the difference, then do the difference, right? So then make it negative and increase the difference. So d plus is equal to 2 into difference. And finally sort the array, because we want the lexicographically smallest, so simply sort it. And now we can get answer only if d is equal to 0, because d is equal to net difference. So finally after the loop, if net difference is minus 1, it means that we are able to get a permutation with sum as x. So if d is equal to 0, only then return a, else return empty vector. So if you have any doubts, comment below. See you in the next video.